Unit 2, Parallel and Perpendicular Lines. This is Lesson 2-3, Parallel Lines and Triangle Angles. First objective, use the Angle Sum Theorem to find measures in a triangle. You saw this in your Edpuzzle video. If you take all three angles of a triangle and put them all together, they're going to form 180 degrees. We're going to use the Exterior Angle Theorem to find measures in a triangle and exterior angles. Theorem. Triangle Sum Theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. So there's another visual, like in the Edpuzzle, showing they add up to 180 degrees. Measure of angle A plus measure of angle B plus measure of angle C is 180 degrees. This diagram actually kind of goes through the proof of showing geometrically why they would add up to 180 degrees. So we draw what's called an auxiliary line that's parallel to side BC. And we know alternate interior angles are congruent, so the blue angles are congruent. Another set of alternate interior angles, so the red angles are congruent. So yes, they total up to 100. Corollaries, which are just a little baby step beyond the theorem we just did. Corollary 1. The acute angles of a right triangle are complementary. Makes sense. If all the angles add up to 180 and you have a 90-degree angle in it, kick that one out. The rest is 90 degrees, so the other two must add to 90, which is the definition of complementary angles. Second corollary. There can be at most one right or obtuse angle in the triangle. Think about it. If you have two right angles, that totals 180 already, then what are we going to do with the other one? Obtuse is just more extreme. Yeah, that doesn't work either. Corollary number 3, the measures of each angle of an equiangular triangle 60 degrees. So 3 angles in a triangle, all congruent to each other, totals 180. They've got to be 60. 180 divided by 3 is 6. Theorem. Exterior angle theorem. The measure of an exterior angle. You get an exterior angle by extending a side. This is our exterior angle that we drew when we extended the side. It's equal to the sum of the measures of the two non-adjacent internal angles. Those are the non-adjacent internal angles. That, of course, is an adjacent angle, shares a side and a vertex. Angle sum and exterior angle theorems. Here's some examples. Find all missing angle measures. Show work and mark angle measures on each diagram. So triangle number 1, that's dealing with the interior angles. They sum to 180. So if we take our 180 degrees and subtract the two we know, 59 and 76, we get 45 degrees. And I marked it on the diagram. Number 2, that's an exterior angle. It's equal to the sum of the two non-adjacent angles. So to get measure of angle 1, we add the 67 degrees and the 62 degrees, and we get 129 degrees. This is an exterior angle as well, so it's the sum of the two non-adjacent angles, but we know the 152 degrees, the exterior angle. So we need to subtract the 115 degrees from the 152 degrees. Measure of angle 1 is 37 degrees. Example 4, find all missing angle measures, show work and mark angle measures on each diagram. in that diagram, the easiest thing to do is vertical angles. No calculations needed. They're congruent. Angle 2 is 42 degrees. We have two triangles. The one on the left, we have two of the three angle measures, and they all add up to 180. So 180 degrees minus the two we know, 50 and 42, gives us 88, and that's the measure of angle 1. The other triangle, the one on the right, has two of the three angles, so subtract the 25 and 42 from 180, and measure of angle 3 is 113 degrees. Let's look at 5. A little more going on this one. I'm going to start with this. Those two form a linear pair, so they add up to 180. They're supplementary angles, so 180 minus the 118 gives us 62 degrees for measure of angle 1. Let's see, angle 2, there's more than one way to get it, but the purple triangle there, the 118 is an exterior angle to it, and we know one of the interior angles, non-adjacent to that angle, so we can subtract the 73 from the 118, and angle 2 has a measure of 45 degrees. This triangle over here has an exterior angle as well, so we can subtract the 49 from the 73 to get 24 degrees for measure of angle 3. Your practice. Here's another triangle, number 1. We know two of the three interior angles, and they add to 180. So subtract the 37 and the 24 away from the 180 degrees. Measure of angle 1 is 119 degrees. We have an exterior angle on this, and it's equal to the sum of the two non-adjacent interior angles. So if we add up the 76 and 52, 128 is a measure of angle 1. This is also an exterior angle, but we know what it is this time, and we know one of the non-adjacent interior angles. So if we take away the 79 from the 104, we get measure of angle 1's 25 degrees. Practice number 4, same directions. Let's start with finding measure of angle 1. Interior angles of that triangle add up to 180, so subtract the 84 and 66 from 180, we get 30 degrees. A couple different ways we can get measure of angle 3. There's a triangle. Angle 3 is an exterior angle to that triangle. So we could add the 30 and the 66 together to get 96. Also, that's a linear pair, so we could subtract the 84 from 180 and also get 96. Interior angle sum of that triangle, we have two of them. We can find the third that way. So subtract the 43 and the 96 from 180, you get 41. Also, that triangle, angle, well, the one with the measure 84 degrees is an exterior angle, so we could subtract the 43, the non-adjacent interior angle that we know from 84, the exterior angle, and we could also get 40. Number 5, we are given that the lines are parallel. It's not marked. Here we go. Let's mark them. Alternate interior angles are congruent. This is going to give us a lot of information. So measure of angle 1 is 1. It is alternate interior with the 73 degrees. Measure of angle 4 is 49 because that's alternate interior with the 49 degrees up there. These two form a linear pair, so if we take the 73 away from the 180, that measure of angle 3 is 107 degrees. These form a linear pair, do the same thing. 180 minus the 49 gives us 131 degrees. Measure of angle 2 is the only one we have left. Those interior angles of the triangle add up to 180. So if we subtract the 73 and the 49 from 180, we'll get 58 degrees, and that's our last angle measure. Another option, we could use consecutive interior angles based on those parallel lines instead of linear pair. We could get measure of angle 3 and measure of angle 5 doing algebra problem. So we need to write an equation and solve. We do have all the interior angles of that triangle DEF with an algebraic expression. So we know that they sum to 180 degrees. Let's do that. Combine like terms, so we're going to tidy up the left-hand side. Let's see, 5x plus 11x plus 9x, and then we're combining -2 plus -21 plus 3. So we get 25x minus 20 equals 180. Add 20 to both sides. 25x equals 200. Divide both sides by 25x is 8. We need the measure of each angle. While we have an algebraic expression for each one, measure of angle D is 5x minus 2. Plug in the value we know for x, and we end up with 38 degrees for measure of angle D. Measure of angle E is 9x plus 3. So we can plug in our value for x, so we get 75 degrees. Now the interior angle sum is 180, so we could find measure of angle F that way, or we could plug into the expression 11x minus 21. There is the expression, plug it in, we get 67 degrees. We have all three. Examples with the algebra, this is number 2. This time we have an exterior angle to the triangle, and that's equal to the sum of the remote or non-adjacent interior angles. So we can write an equation, 18x minus 15 equals 13x minus 11, angle A, plus 4x plus 1, measure of angle B. Combine like terms, 18x minus 15 equals 17x minus 10. Let's get all the x's on one side. So subtract 17x on both sides. We get x minus 15 equals -10. Add 15 to both sides. X is 5. All right. Measure of angle CAB is the same as measure of angle A. We have an expression for it. 13x minus 11. Plug in the value 5, and measure of angle A is 54 degrees. Let's do the same thing for measure of angle ABC, which is the same as measure of angle B. Have an expression, plug in the value. That angle has measure 21. Measure of angle ACB is this one right here. The angle sum of all the interior angles of a triangle is 180, and we know two of them, the 54 and the 21. So if we subtract those away, we end up with a measure of angle ACB as 105 degrees. Now the last one, exterior angle. We know the two remote interior angles, so we could add those two up. So measure of angle DCB is 54 plus 21, or 75 degrees.